Hello and welcome back to ESG Decoded. My name is Erica Schiller and I'm happy to invite Ken Chlapik this morning to discuss Johnson Matthey and their low carbon solutions. Can you please share a bit about your background for our listeners?
Sure, Erica, and I appreciate the opportunity for JM to talk about industrial decarbonization with CLEANPACETM and also the fact that CLEANPACETM and JM have been working together. Really enjoyed what we've been doing together. Myself, I've been with the industry since the 80s, and since the 90s, I've had a focus on hydrogen production. I've been involved with the growth in hydrogen that we've seen that exists today, a tripling of that production level over a period of about 30 years. The bulk of that is really for producing clean fuels for us, low sulfur fuels, low sulfur diesel, low sulfur gasoline. And now we're looking into this energy transition, looking at hydrogen as an energy vector for that. And we're looking at a magnitude larger production and capacity of hydrogen to help achieve that. So we're excited to be involved in that. I'm excited to have my career, a part of my career, be involved in that as well. As far as for JM has been around for over 200 years. But that 200 years, they've been able to be around by evolving and changing to meet our customers' needs and to help our customers through that. A good portion of the last probably 50 years has been around helping managing emissions from transportation mobility, catalytic converters, and devices for heavy-duty diesel applications, as well as looking at catalysts in the refinery space, again, for producing these low sulfur fuels, hydrogen production catalysts, additives for fluid catalytic cracking that has helped to remove the sulfur from those emissions. And then we've also been involved in petrochemical and continuing to improve the production of ammonia and methanol in those areas, along with other chemical licenses that we have. So that's been a real strong point of ours.
So that's a broad list. I mean, I heard heavy industry, I heard some energy, catalysts, specialty chemicals. So Johnson Matthey kind of spans a broad range of industry, and then you're saying that your role has also been kind of varied throughout that time with Johnson Matthey.
Yeah, it's mostly been around the hydrogen area, and so I've been spending a lot of time with our refinery customers. But this role I have now is really around our new LCS business, low carbon solutions business that we've created over the last few years, and it's really to focus on those existing producers of hydrogen, methanol, and ammonia to help them decarbonize their plants and their facilities using technology that exists today, but the focus on decarbonization hasn't been there until it's the strongest right now.
Okay, so you're looking at retrofitting existing plants to help them decarbonize.
That's the area that I focus in. JAM has a portfolio and a program of decarbonization that covers broader than that, and sustainable fuels production. But for my global market manager role, that's the area I'm focusing on.
Great. And to set the stage, we're talking about industrial decarbonization, right? That's kind of why we are here today, to talk about ideas, what we're doing in the space, what the challenges are. Can you talk about why it's important to Johnson Matthey, and what do we mean by industrial decarbonization?
So industrial decarbonization, if you look at the hard-to-abate areas for decarbonization, you're looking at, for the globe, about 20 gigatons per year of CO2 emissions that go into the atmosphere. Half of that is industrial emissions. And in those industrial emissions, the top two areas, number one is iron and steel production, number two is cement production, and the third one is chemical and petrochemical operations. And when you look at those petrochemical operations, chemical and petrochemical operations, 70% of them are produced using a steam methane reformer and ultimately producing syngas to make those chemicals. And so within that, the main areas are hydrogen, methanol, and ammonia. So they're right there with our customer base and the technologies that we have to offer And so it really makes sense for us to be involved in that area of helping them develop their decarbonization roadmaps and decarbonizing those plants and those facilities.
That's awesome. So when you talk about syngas, I'm not sure all of our listeners really know what that means. Can you share a little bit more? What do you mean by that? And how is it used?
Syngas is produced by kind of two routes, and I just talked about hydrogen, methanol, ammonia as the main areas that consume that syngas. That syngas predominantly being produced by a steam methane reformer, an SMR. But there's also the feedstock that goes into it. It's pretty mixed around the globe. There's probably about 50% of the emissions are due to coal-fired plants, as well as natural gas-fired plants. And so those hydrocarbon feedstocks are used in a steam methane reformer to ultimately make this syngas, which is a combination of hydrogen, carbon monoxide, CO, and carbon dioxide, CO2. And it's the CO2 emissions that we're tending to really focus on, as well as some residual methane and hydrocarbons that could be in that too. But that's kind of the building block, the engine to really provide these other areas of hydrogen, ammonia, methanol, and onward to other chemicals.
Awesome. And so I just wanted to pull out, you said 70% of the 10% of CO2 emissions associated with heavy industry are associated with SMRs, the steam methane reformer. So you're tackling a large portion of our overall industrial footprint by helping those syngas production to reduce their emissions and potentially, bolt on to carbon capture and storage and reduce emissions completely or more than 90%. So that's a big challenge, a big chunk of our global impact and industrial impact to climate change. Can you also share, Johnson Matthey and CLEANPACETM announced a partnership to advance low carbon solutions last summer. And how do you feel that CLEANPACETM and Johnson Matthey can work together to impact industrial decarbonization?
Right. So one of the things we've been working on with our low carbon solutions business is actually establishing an ecosystem of partners. I think everyone's talking more and more out in the public domain about to execute this energy transition at pace and in an accelerated way. We have to really work together with other companies, finding those capabilities that we have, aligning them with other capabilities so that we can progress that as well as we can. The CLEANPACETM relationship we're really excited about. One of the realities is that, even if I just look back a little over a year ago, we really didn't know how legislation was going to play out. It was really fragmented. You had a few states doing things in the U.S. There was some things happening in Canada and Europe, but very fragmented. And still, even with the national agreements that have been happening, like or national legislation that's been happening, like the IRA and the infrastructure bill in the U.S., things have been happening in Canada and also in Europe. There's still a lot of states, provinces, and countries in Europe that are defining kind of their own legislation and rules around how they are going to utilize clean energy, clean hydrogen production. And so with that, we really felt it was important to have a company like CLEANPACETM with us that understands those regulations very well, that's involved in some of the areas of carbon offsets and now renewable offsets and other areas that are starting to, and credits that are starting to get involved, that really understand the mechanics behind those incentives, the mechanics behind the aspect of carbon capture and storage. And so we're really relying on CLEANPACETM to do that. CLEANPACETM really helped us out quickly by providing us a tool to help determine the carbon intensity and the impact of some of these different streams. Because a lot of the regulations are basing these incentives on lowering the overall carbon intensity, the technologies that can lower the carbon intensity of the technology or the production, the clean energy production that you have. And so the typical or the future way of really analyzing that is through a life cycle analysis. A life cycle analysis is really, kind of a compilation an evaluation of different inputs and outputs and the potential environmental impacts of those on the product. Normally, and I'm sure CLEANPACETM can talk to me more about that than I can, but normally it's a process that can take anywhere from 6 to 12 months to really do that well around a particular plant production area. And so what CLEANPACETM was able to do was distill that down to something that a tool that we could work with and work with our customers on to try and explore the optionality that could be there and where these incentives could play. Because one of the realities is that to decarbonize costs money. And the ability to get these kind of projects through a company's capital program is really challenging. And these incentives are wonderful, and they're making the difference, but they still need to be reviewed and seen compared with the different technologies and what they do against that. And we're really appreciative of what CLEANPACETM's been able to help us with there.
So I just wanted to point out, you said IRA, and that's the Inflation Reduction Act, and that's in the U.S. It was passed about a year ago. And thanks for sharing a little bit about what are those challenges. Can you delve a little bit more into what are some of the key challenges for industrial decarbonization? Obviously, cost being a big one.
Yeah, I think that's one of the biggest things we've seen that our customers have seen, right? And I think there's also, depending on who the customer is, there's a lot of optionality that's available to them. I think what we're also seeing is that our customers, while they're looking to have a decarbonization program, a roadmap, trying to set targets for net zero in a 2040, 2050 time frame, they're realizing there's a lot of ways they can do that, a lot of routes they can take. And there's not a lot of capital availability to do that. So they really need to look at how they can make a positive business case and still drive that decarbonization to occur. And so many things like using hydrogen vegetable oil to get to biofuels, there's a lot of strong incentives there to really make those positive business cases there. With carbon capture and storage, a lot of the early areas that are being looked at are LNG, gas processing, ethanol. So those areas are being looked at first, and then some of the things that we're talking about, decarbonizing hydrogen plants and ammonia plants and methanol plants, is kind of a little bit further down the line, a little bit more complex. The economics still need a little bit more push there, and that's why being able to work with CLEANPACETM and understand some of those incentives that could be there, some of those options that can be there of using things like renewable natural gas or biogenic feeds in some way, wastes that are existing in the waste and off gas that are existing in the facility, those can make a real difference to getting a project over the line or not, making a positive capital business case for a customer.
Okay, great. And I just wanted to pull out, you mentioned using bio oils or bio-based feedstocks. Those could be replacing petroleum products, right? That's how you're kind of helping to decarbonize, is using a plant-based product instead of a petroleum-based product as a feedstock.
Yes. And I think one of the things that's being realized is that those hydrogenated vegetable oils, those biogenic type feeds, many of them are lean on hydrogen. And so customers are actually needing more hydrogen to process those. So what we're trying to do with the technologies that we're developing is, or at least putting out into the marketplace, making available, is the ability to not only decarbonize, but actually add production to the facilities of a way that can complement that extra demand that's there for these different processes.
Okay, so you're looking at optimizing a hydrogen plant to produce more hydrogen because these plant-based feedstocks need more hydrogen to get to the finished product.
Yes, yes.
Okay. Great, that's great. And In prior conversations, you've shared many industries, including your customers, made 20% reductions in capital budget cuts in the pandemic, and they haven't raised them back to historic levels. How do you make the business case for industrial decarbonization at these lower capital numbers? And can you share some near-term game changers for industrial decarbonization?
Right. Well, I think one of the ways that we just kind of quickly talked about is by actually producing more of the product that they sell. So that tends to give value to these projects beyond just the decarbonization and the incentives that can go with that. And so that's a way of getting those projects across the line. And we've kept that in mind with all of the CLEANPACE technologies that we've established under our low carbon solutions business. But I think some of the other ways that are starting to happen there, and we see customers doing that. I mean, I think if you look at from a large space of all that CO2 that needs to be captured, still carbon capture and storage of that CO2 is going to need to be there to accomplish the high levels of decarbonization that we're looking to do over this journey to net zero. But in this immediate time right now, I think what customers are seeing is there's an opportunity to utilize that CO2 to create products of value, and that tends to make a more positive business case. And Johnson Matthey has a number of different sustainable fuels technologies. We have examples of those projects occurring on the marketplace, doing things like using our FT cans technology with Fulcrum and BP for the project that they have, the Sierra project they have.
What is the Sierra project?
So it's actually converting municipal waste into sustainable fuels, and cool. Producing about 11 million gallons of renewable synthetic crude oil per year. I was starting to talk about the Repsol Aramco project that's using our JM Hycogen and JM FT cans technology. And there we're looking at a plant that will be one of the first to use renewable green hydrogen and CO2 as its only raw materials. And so we're progressing that. It's about 2,100 tons per year of sustainable fuels.
And that's often called e-fuels as well, right?
I think that term tends to get put on that as well. I think there's with e-fuels, we're looking at trying to produce those fuels without some of the traditional feedstocks that had been there for producing those. So we're looking at trying to do predominantly renewable kind of feeds to produce those. Yeah,
and taking a CO2, either a waste product or a direct air capture, and then adding hydrogen to make a fuel.
Yeah, and then that's one of the project that we're doing, the Haru Oni project in Chile, is actually exemplifying that. So it's using a combination of producing green hydrogen, electrolytic green hydrogen, and CO2 recovered from direct air capture to actually produce sustainable fuel. And I think by 2026, it's going to be producing about 550 million liters of that sustainable fuel. And with the intent to build that production up, we're working with a company, and Siemens is involved in that, Porsche is involved with that, a company called HIF that's driving these actual projects. So it's really exciting space for us to work in as well. And then a little bit on a different area, we're working with Marathon Environt to use our technologies to go from biofeeds and kind of a James bioforming technology to actually create intermediates for future chemical production from these biogenic type of feeds and streams. And so that offers, I think, a lot of near-term opportunity to start doing that kind of intermediate chemical supply switching, right, to some of these areas, which is exciting.
Great. And, as we think about what can we do today versus future state, are there some kind of midterm options for, low capital, mid capital, and high capital solutions to help industrial decarbonization?
Well, I think I really appreciate the question. And I think our program that we have in JM decarbonization type of technologies really feeds into that well. What we're seeing, companies are trying to, so they set their targets for net zero. They've trying to produce some kind of roadmap of how to get there, and they're realizing that the optionality is grand. There's a lot of routes they can take. They need to understand these incentives that are being there well that can make the capital projects progress into their programs. And so I think what we see them doing over the past maybe 6 months or into this year is looking at how they can establish low capital, mid capital, and high capital solutions. And so on the low capital side, JM has traditionally, with its customers, really helped them improve the efficiency of their production processes. And even the licensed technologies that we've continued to evolve those and improve on the efficiency of those. In particular, we've got a product called our stackable structure reactor, which actually makes a step change in these steam methane reforming reactors to not only lower the CO2 emissions, reduce the CO2 emissions in those production units, but also reduce the energy usage, the intensity there, and can allow a customer to do probably somewhere in the area of a 10 to 20% uprate in their capacity. So that's kind of a low capital way of enabling them to start to decarbonize, start to address that area.
So you're squeezing more, just so I understand, you're squeezing more production out of the existing plant and using less energy.
Right.
Oh, that's great.
Right. So, it's not to the high levels of decarbonization that most roadmaps are looking for. And by that, I'm talking about 90, 95% plus capture of the CO2. But still, we're doing something in the area of 10 to 15% reduction in that CO2 with these methods and technologies that we provide. So that's I think getting more interest right now as companies are trying to navigate through this, trying to balance their capital through the projects that they have. But on the midterm capital side, that's the CleanPace technology. And really what we're doing there is capturing all the CO2, first bringing the CO2 from all the sources that are kind of in a hydrogen methanol plant, bringing them to the process side so that we can capture them in a very established way. And the technologies have been out there for decades on being able to capture CO2 on the process side of a production unit, like a syngas production unit, like hydrogen or like methanol. And so by being able to do that, we can get to these very high levels, 95% plus capture, which is very attractive to the customer. But we're also able to have this optionality, at least, of extra production capacity, which, like I said, is that amount is attractive for some of the things that customers are looking to, the increased processing that customers are looking to do. I think the other thing that we do is it is a lower capital solution. It's also a kind of a bolt-on solution. So customers are able to make these changes kind of within their major turnarounds without much disruption to the existing plant. And it also has a low profile. And that's really important. As we start to look at some of these decarbonization technologies, they can actually produce more plot space than the syngas production unit themselves. And
so you're talking about the footprint of the technology. There's only so much space on an industrial facility. And so you're saying your technology can kind of fit in a smaller space so that the plant can still operate, they can still, get around and maintain all the facilities. And so my understanding of that second solution is you're aggregating the CO2 from different point sources to one, you said process side, but basically kind of one source so that it's easier to collect it. And then once it's collected, then you could either sequester it underground, geologically, or utilize it in some way. Right.
Absolutely. And that's we're doing that with technologies that have been around for over 30 years. It's underpinned by our advanced reforming technology, which is unit technologies like autothermal reforming or gas-heated reforming, actually changing the way you reform the feedstocks into the syngas so that you can do it much more efficiently. and much more compact to intensify. And that's how we're able to address some of those areas that I just spoke of, some of the values that are there that I just spoke of. And then, we're working with other third-party partners that are well experienced in the area of CO2 capture, further parts of our ecosystem that we're building to try and help the customer have a more complete solution.
Okay.
The third area, the high capital area, is also getting a lot of attention and a lot of examples of projects with that. But that's our LCH, our low carbon hydrogen production technology, getting down to probably 10%, if not even less, of the carbon intensity that exists today with the steam methane reforming technology that's used for this syngas. And so really intensifying how that hydrogen is produced in a very large scale way. And so, for example, some facilities are looking at moving all of their fuel usage over to hydrogen. And with those kind of large scale demands, the LCH technology can fit with that well. And then also in the areas of hydrogen hubs that are starting to surface, those hubs are looking for large production of hydrogen as a energy vector within those hubs. And this technology has been chosen to do that. We've been chosen for the HyNet technology in the UK and also the Saltend hydrogen hub that's happening in the UK. And we've also been chosen for a North American facility that's doing more of what I talked about, replacing all of their fired heaters that would normally be using fresh, if you will, hydrocarbons and producing CO2 from those. We're replacing those with hydrogen firing.
What you say is hydrogen firing. I think that it would be helpful for our listeners to understand. Basically, when you look at a refinery or an industrial facility, there are needs for heat, and there are needs and that heat could be steam or something else. And then there are also needs for energy in different parts. So you're saying that traditionally you might use natural gas boilers to produce a bunch of steam as part of the production to produce your gasoline or your finished products. But if you instead, and it's hard to capture the CO2 from every boiler and every different point source of a refinery or other industrial facility. So instead you can produce hydrogen in a very large facility, capture the CO2 from that. And then if you use the hydrogen to fuel your boilers and your other parts of the refinery or industrial facility, then those emissions are just oxygen, right? The hydrogen doesn't produce CO2 when it's burned. So you're still getting heat, you're getting the energy, the steam, whatever you need for your industrial process, but there's no point source emissions from those individual boilers or heat sources.
Correct. And I think one of the challenges of moving to that is that there already has been, and refiners are great at looking at efficient ways of operating their facilities and their process, and have evolved wonderfully over time. And so a lot of what they were doing is they were firing those heaters with flare gas in different areas and reducing or eliminating the flaring of these gases.
And that might reduce their cost of buying conventional natural gas from a utility because they're using their own process gas. Okay.
And so now the switch is using some of those off gases still to actually to produce the hydrogen in the LCH technology. And we have those examples at projects that are doing that as well.
And then you would capture the CO2 from that hydrogen facility. Okay. Okay.
And at those levels, I think, normally carbon capture and storage is being looked at for those levels. Because, one of the realities is, and like I talked about a little bit earlier, is to really get the globe to net zero, the amount of CO2 that has to be captured or that needs to be stored in the ground. There's going to be a good portion of that has to be stored. But at this point in time, there still is a lot of opportunity to utilize that CO2 to produce some of the products that we have traditionally used fossil fuels to do.
Yeah, and so you had mentioned in our previous conversation, there's some trends that you're watching for industrial decarbonization advances and the CCUS carbon capture use and storage market evolves. Did you want to share a bit about that?
Yeah, I think one of the things that we're looking for in the near term is actually the IRS is going to start defining, I think, hopefully by the end of this year, kind of how these incentives are actually going to be handled over the life cycle of a production facility. And so I think that's going to give a lot more clarity to be able to put together these business cases and capital project cases for customers. So we're looking forward to that as a means for kind of moving us out of this kind of paralysis right now of all these opportunities and hopefully establishing where those clear opportunities can be. I think also what's happening.
Just on that, so you mentioned the IRS, so that's related to U.S. federal, the Internal Revenue Service, and they're defining in the Inflation Reduction Act how the incentives are going to pencil out for 45Q, which is an incentive associated with carbon capture use and storage, and with 45V, which is an incentive associated with low carbon hydrogen production. Some of the rules were kind of set at a high level, and we're waiting for clarification on the details of that to really understand what are the exact requirements for an industrial facility to maximize the incentives and fund their decarbonization.
Correct, because I think right now people are making some assumptions. They're making valid assumptions with how the legislation has been written. But those mechanics are going to be really important to make sure that incentive value is part of the overall case of what's being done. I think maybe an aside, I know we're talking about the U.S. a lot in there, but one of the projects that we've also been involved with our CleanPace technology or our low carbon solutions technologies is in Europe, in Northern Europe, the Project AIR that's been strongly funded by the EU Innovation Fund. And part of that is around taking traditional kind of methanol production that would be fossil fuel based and actually gathering off gases from this site in Perstorp, Sweden, and using those to produce the methanol that they would traditionally use fossil fuel-based methanol for. So it's starting to actually demonstrate how we can, with our technologies, with JM's technologies, we can help a site actually utilize the off gases either in their facility or in their neighboring facilities to actually produce these same chemical needs that a customer may have.
Okay, so it's taking a waste product and turning it into a finished product and displacing a petroleum-based product.
It's exciting. It's kind of aligned with what we just talked about with actually converting using off gases to produce low carbon hydrogen at a large level to fire heaters in a refinery complex which is one of the, I think it's the third largest area of CO2 emissions that a refinery has. But firing that with hydrogen, and so it kind of complements that kind of approach as well.
So that's really interesting, Ken. Thank you so much for sharing your knowledge with us. I mean, it's clearly a really complex subject, and it's exciting to see the incentives that are coming out from both U.S. government, state governments. We're seeing Canadian regulations. We're seeing, Europe and other regions are responding. And some of that is incentives, and some of that can be, that's kind of the carrot, right? And then the stick might be carbon tax or some other regulatory requirement to make those reductions. So it's clearly a complex subject, and I'm sure there's a lot more we could get into it. So maybe we'll have you back on to dive a little deeper. But thank you so much, Ken, for your time today.
Well, thank you, Erica, and I really appreciate CLEANPACETM and what they can do for JM and our ecosystem as we progress our low carbon solutions.